Now allow me to welcome another interesting keynote speech by Dr. Pramod Kumar. He's the Director of Research and Innovation, Quantum Lays Laboratory at Abu Dhabi, UAE, and he's going to be telling us more about quantum-enabled photonic technology for the sustainable future. Please join me welcoming Dr. Kumar.
Good morning, everybody. So it's a great pleasure for me to be here, and thanks to Malak for giving me this opportunity to share my experience with you guys. And so today I'm going to talk about the quantum-enabled photonic technology for sustainable future. It's already being discussed since yesterday, and it's concrete discussion already been done about the quantum technology. But just to add up this discussion, I am going to share my experience about the complex functionality of optical chaos in the context of quantum random generation and decision making. Dr. Samant and Dr. Moon already discussed about the Ising machine and the QRNG in the morning session. But I'm just giving the flavor about how to use optical chaos for quantum random generation, and further these numbers can be used for decision making or optical Ising machine. So let me Yes, let me explain, throw some light on who we are and what we are going to do, research in this UAE-based Quantlays company. So Quantlays company is actually the subsidiary of International Holding Company, and Mr. Sueb Basir is the director of ISC, and Mr. Siraj Siddiqui is the executive director of Quantlays. So Quantlays is actually R&D platform. We are designing and development of photonic-enabled technology for various applications like imaging, sensing, computing, and of course biophotonics also. So quantum photonics that could be used to make other technology faster and better and more accessible. This was the message we are doing in the Quantlays. And so our history is, this is very new company, it's not very old. We started in 2020, and with the breakthrough of corona time, we have invented laser-based corona screening technology, and it was successfully deployed in UAE. And after this breakthrough, we moved on. July 2020 is deployed, and June 23 we established 4 divisions at Quantlays laboratory. One laboratory dedicated to ultra-fast laser system, and another 2 laboratory for quantum photonics and quantum biophotonics, and of course 4th laboratory is dedicated to characterization, or because finally we want to fabricate our technology in cheap scale, so we want to fabricate in-house this device. So today I'm going to discuss about how to make a decision. So inspired by the human mind or human brain, if you look at, if you are in a confusing state, you would be the more efficient decision maker. So being a confusing state is the good for unbiased decision making. So how to implement this idea in real life application? So the motivation behind this is that not only this decision making, we are living in a digital age and we are sharing data, huge data every day. So how to control this data? And we have a huge data file depending on different parameter, different input, various output, how to optimize the system. So my question is that can we really design and development of photonic enabled decision maker for efficiently addressing challenge within the relief of hard computational problem? So hard computational means if your processing time of your computer increases exponentially with the problem size, this is the hard computational problem, and you can call it NP hard problem. So we are designing and development of technology which we convert this NP hard problem into P or polynomial time problem. So here my idea is to use chaotic behavior of the light, because chaos is a destabilized state of a light, and they are coexist in a system. And if you use the chaotic itinerary among this destabilized state, and it will resemblance as the optical brain functionality or brain functionality. So I can use this chaotic iterary phenomena with multiple stable attractor called chaotic attractor, coexist and variable dynamical system move around the quasi-attractive state. So you can understand this coexisting attractor state is more or less equivalent to this entangled state in quantum. But it's not entangled state, but it's look like a entangled state in quantum. So, but this is classical state. So this coexisting state one can use for decision maker. So the plan of my discussion is going to be in this way. We will discuss about how inherent character of chaotic attractor allows a manipulation and control of system, and how to generate an optical entropy source for decision making, or not only for decision making, we can use this entropy source for cryptography, for communication, safety, wherever you need a security and safety, then you can use this quantum random generation. Dr. Moran already discussed about in the morning in this regard. And I'll come to after that photonic decision maker, how to make a decision in time, space, but if we are living in a real life, and real life is not only time and space interacting with you, it's a spatio-temporal space interacting with you. So we are looking for a photonic platform where you can implement space and time both all together to make a decision. Finally, I'll come to the experiment, theory, and conclusion. Let me start from the very beginning. I just want to give you the flavor of what is the fundamental ingredient in a laser system. So you have three ingredients for lasing action: absorption, emission, and stimulated emission. The reason of projecting these things over here, because I'm going to use this spontaneous emission in my idea further. So this is these three basic ingredients for the laser action when laser is running in free running state. Now, we are going to use semiconductor laser, because semiconductor laser is very sensitive to optical perturbation, and you can manipulate and control laser system according to your requirement. So semiconductor laser is a fascinating element for any technological application, because but the problem is that you cannot make it chaotic unless and until you put in an external perturbation. So because for semiconductor laser, electromagnetic field and the carrier density, there are two variables sufficient to explain semiconductor laser. So you need to add 3 degree to generate a chaos. So how to add these 3 degree? You have three options. You put your semiconductor laser in optical feedback or optical injection and optoelectronic feedback. It's up to you which technology suitable for you. Every technology has its own beauty and own drawback, but I'm using optical feedback for generating optical chaos. So this is the experiment. This is the experiment I have done in my laboratory, and I have designed an optical cavity. And if you can see that if you put a laser system in an optical feedback case, then the dynamical instability come into picture. So these dynamical instability may open the possible ways of chaotic communication. But on the other hand, these dynamical instability you can use for decision-making purpose or optimization purpose. Of course, you can use optical injection technology. You put many semiconductor laser in optical injection case, and the control parameter decided what kind of regime you want to reach. So the number of adjustable control parameter and their combination is so high. So new dynamical regime are still being observed by carefully adjustment of laser system. Not only semiconductor, you can quantum structure-based semiconductor laser system, because finally you want to fabricate your device on chip scale. So quantum nanostructure-based semiconductor is suitable candidate for the chaos generation. So you can use edge-emitting laser, bulk laser, quantum dot laser. You will have the chaotic regime everywhere. Of course, if you use quantum dash laser system, and you put the laser system in optical feedback, you have highly chaotic regime depending on the control parameter. So, diverse optical platform for light-enabled technology decision making is a single photon decision maker, or it could be a chaotic-based decision maker, or it could be an optical injection-based decision maker. You can use many technology, and people are using many optical platform for depending on the requirement. Here we have developed quantum randomness generator by optical feedback. And the beauty of this setup is because we are dealing with two noise at the same time. If you look at, if you remember, I just show you that the first spontaneous emission come into picture. This spontaneous emission actually coming from the quantum nature of light, and you can call it quantum noise or quantum phase fluctuation. But once you put the semiconductor laser with optical feedback, then a particular feedback is strength and the time delay and coupling, you will have a dynamical regime. So these two dynamical regime actually competing each other in a self-feedback system. So if you are able to control chaotic noise and quantum noise in such a way that when the moment your quantum noise actually overlapping to the classical noise, then you can call it quantum random number generator. Otherwise, chaotic noise is not quantum, it's classical. Of course, the initial condition dependency of chaos will give you the unpredictability, but it still is a classical. So we have done this experiment in our laboratory in Abu Dhabi, and we have successfully developed this setup. A proof of principle experiment is already there in the lab, and now this is the result of our QRNG in the lab. So you can see that you have a highly chaotic regime observed in the system. If you change the control parameter, you can change the randomness of the system depending on your requirement. So we are calling it the on-demand QRNG system. So this is the beauty. You can manipulate and control laser system according to your requirement. You can have different dynamical regime in the chaotic regime, low frequency fluctuation, high frequency fluctuation, and I'm projecting the large number of mode is actually coming out from the laser system, and you can call it external cavity mode. And these are the chaotic itinerary among the attractor ruins. So this system is actually wandering among the destabilized mode and finally reach the maximum gain mode. And this maximum gain mode will give you the answer of your optimization. So you can use this idea for decision making. This is the setup of our optimization system, and it's a beautiful intelligent system, and Dr. Sawan is already discussed about Ising model. So it's a look like Ising model, but we are using chaos here, not Ising model. So this is the system we are running over here in booth number 9. If you are interested, you can visit us, our booth. So the idea behind that, you start with the chaos or randomness. Here I'm taking randomness from the chaotic system, and this is the first step. You upload this QRNG on the SLM and shine a laser light on it, and you have a reflection part as a pattern of this first step, and you modified your phase, and then again upload on the SLM and let them free to find the optimal solution of the system. If you look at very carefully in the right side, the whole oscillator, we are using 64 oscillator for this experiment. The all oscillator are actually jumping around the chaotic regime, and after taking 200 or 180 round, one candidate is start winning. So you can use this idea for the optimization system, for the multi-armed bandit problem solution. So this is the fascinating platform we have building up in our laser lab. You can use it for, so this is the ready quantum computer to deployment. These are the papers or references I have used for this presentation. Anyone can read it and go through it. And this is the open problem because scalability is the issue. 64 candidate or 64 variable are not sufficient to design the setup, computational setup for the optimization system. So how to scale up the system? This is an open problem. You can use delay coupled oscillator system to scale up the system, or you can use any diffractive optical feedback to increase the scalability. So, but to the best of my knowledge, actually only SLM and DMD are being used to design this photonic intelligence system for optimization or decision making. So this is the idea. If you use coupled laser network, and delay will make this system infinite dimensional space. So you will have infinite coupled cavity mode in your output, and the reorganization of this mode will give you the optimum solution of the system. So this is the idea one can use for further implementation. So this is the things actually I want to share with you two guys. If you are interested anymore in this regard, so please come our booth number 9 and we will discuss more into detail about our experiment. Thank you very much.